Alright, geometry students, these are some Polygon PBU hints, and specifically these are hints for problem set number 2, which is on page 276. Let's get started. So the first example on page 276, it says, what is the sum of the measures of the interior angles of a convex 12-sided polygon? So we know the number of sides. They're telling us right here that our n is equal to 12, number of sides. The other key words here is that they're telling us that we're looking for the sum, so all of the angles added up, of the interior angles. And if you look back at worksheet number 3, you'll recognize that there is a formula that we developed to find the sum of the interior angles, which we're going to abbreviate int angles. And it was simply taking 180 and multiplying by the number of triangles that could be formed, and the number of triangles is going to be 2 less than the number of sides. You remember that when we had a polygon, if I divided it into triangles, I could then count the number of triangles, and of course it's 2 less than the number of sides. So I always want to start with these problems by writing down my formula, and then I can plug in the given information. And so I was given that n equals 12, so it's simply going to be 12 minus 2, and then I can use my order of operations to work this down. So it'll be 12 minus 2 is 10, and therefore 180 times 10 will simply be 1800 or 1800 degrees. And really, that shows the answer just fine because I've clearly identified what it is I'm looking for up here. Alright, let's go ahead and take a look at the next problem. So example number 2, it says, what is the measure of each interior angle of a regular 20-sided polygon? So again, they've told us what our n value is. The number of sides equals 20. In this case, though, they're asking for each interior angle. And I can do that because the polygon is regular, meaning that all of the angles are the same, right? It's going to be equiangular as well as equilateral. And so we do have a formula also for finding each interior angle if the polygon is regular. So I'm going to write down my formula. Again, this comes from worksheet number 3. So each int angle for regular polygon, and it's going to be, as you might remember, the sum that we just used on the previous problem. So 180 times the number of triangles, which is n minus 2, 2 less than the number of sides that we have. That's how many triangles were formed. And of course 180 is the number of degrees per triangle. And then I divide that entire thing by the number of angles that I have, which of course will be the same as the number of sides. And now again I can simply plug in the information here. So I'm going to have 180 over 20 minus 2 all over n, which is simply 20. I can work that down a bit more, and there's a couple ways that I can go about working this down. I can either just simplify the top and then put that all into my calculator. So I could do this. 180 times 20 minus 2 is 18, all divided by 20, and then put that into my calculator all in one go. Another possibility would be that I could, if I didn't have a calculator handy or I wanted to work it out a little bit by hand, I could see that 20 goes evenly into 180 exactly 9 times. And so then I'm left just multiplying 9 times 18, which I believe we'll find is 162 degrees. Again, I don't really need to necessarily box that. I guess I could. If I wanted to, I could box the answer down here. But because I clearly identified what it was I was looking for from the beginning, I don't really need to write out a whole answer. All right, let's take a look at the next problem, example number 3. So this tells us that a convex pentagon has interior angles that measure 90 degrees, 100 degrees, 110, and 120. And then that's us find the measure of the fifth interior angle. Well, we'll remember that a pentagon is n equals 5. It's a 5-sided figure. And we're also told that it's convex, meaning that it's not going to have any indents. So I might start this problem just by making a quick sketch. So I can sketch a pentagon. I'm going to make sure it's convex, meaning that it's got no indents. And then I could take that, I'm going to make that just a little bit bigger. And then I could go ahead and add in the angles that I'm given. So there are my angles, 90 degrees, 100 degrees, 110, and 120. Now I'm asked to find the fifth angle, so it would make sense to put x here, x degrees. Now, some people might be really tempted to look for a pattern and say, wait, 90, 100, 110, 120, this must be 130. And it might be 130, but we don't know that for sure. The correct way to solve this problem instead is to find out what all of the angles together must add up to, and then set the sum of these equal to that. So remember, for a pentagon, you may recall that if I were to divide this into triangles, that I would get 3 triangles. And because I have 3 triangles, if I multiply the 3 times the 180 degrees, then the sum for the whole thing would be 540 degrees. Now, of course, I could do a whole formula for that as well, but this might even be something that you just simply memorize. Either way, though, it's easy to work out. Okay, so now I want to try to find my equation. So my equation here will be adding all of my angles. So I've got my 90 degrees plus my 100 plus my 110 plus my 120 plus x, and that's going to be equal to my 540 degrees. So go ahead and solve the rest of this one out by yourself. When you're finished, make sure you answer the question. So I'd say the fifth angle measures, and then whatever answer you end up coming up with there. And that would be our answer for this particular one. All right, let's take a look at the next example. Number 4, so this says a convex hexagon. So again, convex meaning no indents. And hexagon tells us that it's going to have n equals 6 in this case. Has exterior angles that measure 32 degrees, 54 degrees, 67 degrees, 72, and 100. And then what is the measure of the 6th exterior angle? Now, I could make a sketch for this as I did previously. And that would look like this. So it's a 6-sided figure with no indents. And for the exterior angles, of course, I would need to make my sort of pinwheel here, and then I could put those angles in. But you could also skip this step, because we know that, of course, the 6th angle would be our x degrees. We know that for any convex polygon, the sum of the exterior angles is always going to be 360 degrees. Doesn't matter how many sides it has. So really, I can take these angles plus my x and add them up to make 360. Okay? So go ahead and solve the rest of this problem yourself. Don't forget at the end that you're going to want to say the 6th exterior angle measures, and then finish answering the question with the angle that you find. And then, of course, you'll box that. All right, let's take a look at the next example. So number 5, it says, find the measure of each exterior angle of a regular nonagon. Okay, so again, key words here. Each exterior angle, so that should give us a hint as to which formula we're using. Regular meaning that it's equiangular and equilateral. And nonagon tells us that n in this case is equal to 9. Remember, a nonagon is not an n-gon. A nonagon actually has 9 sides. An n-gon has n sides. Okay? So a nonagon is not an n-gon. Just be careful with that. So look back on worksheet number 3. And I'll find that for the measure for each exterior angle is simply going to be the sum of all the angles, which of course we know is 360. And then we're going to be dividing that by how many angles there are, because each one will be the same. The number of angles will be the same as the number of sides, so I'm simply dividing by n. Okay? So you can go ahead and finish out this problem on your own from here. There's one additional one that I wanted to look at. So you can pause the video for now and continue on with numbers 11 through 14. But when you get to number 15, it says this. In exercises 15 through 18, you are given the measure of each interior angle. Okay, so let's see what we're given. We're given the measure of each interior angle of a regular polygon. And then it asks us to find how many sides does the polygon have. So this angle here then, 162, is the measure of each interior angle. So that's what this 162 stands for. So I want to look back at worksheet 3 and the formula, which is the one that I want, is going to be the one for each interior angle. And as we found before, that's simply equal to the sum of all the angles, 180 times n minus 2, all over the number of sides or number of angles that I have that I'm dividing it between, so all over n. In this case, though, instead of plugging in an n to these places and finding each interior angle, we're going to be plugging in the interior angle and solving for the n. So in order to do that, I simply plug in 162 in place of each interior angle. So I'm going to have 162 is equal to 180 times n minus 2 all over n. I can now, the problem here is that the n is on the bottom, so I want to get rid of that. So I'm going to multiply both sides of the equation by n. And when I do that, the n here will cancel with the n here, and I'll be left with 162n equals, at the same time I could distribute this 180 to both of these pieces. So that's going to give me 180n minus 360. Now I have to get the n's all together on one side. Probably the easiest way is to move the 180n over by subtracting it from both sides. When I do that, I'm going to end up with this canceling out, and I'll have negative 18n equals negative 360. And then finally, to get n by itself, I can divide both sides by negative 18. And I should find that n is equal to 20. So I want to answer the question, and I'm going to say the polygon has 20 sides. All right, folks, that's it. So again, look back at worksheet number 3, look at the formulas, look at the example problems. You should be able to work out the rest of the examples in this problem set on your own. But of course, come see me for help if you have additional questions. Good luck.